test to see if I move my periodic table, if it will actually grow on the page. Hey! Hello, happy Monday, ladies and gentlemen. Welcome back to chemistry. Hope you guys had a great weekend and a happy Palm Sunday. Don't forget the reason for the season. So, this week we're going to be talking about oxidation and reduction. So oxidation reduction is something you're going to be doing a lot of if you ever take college chemistry, so I figured it's important to cover now. So when you get there, you're like, wow, this is really easy. Man, Mr. Brown prepared us really well. That's what I live in my fantasy world. I'm hoping that you guys one day come back to thank me. But anyway, so we're going to be taking this slow. You can follow along in the book. Before we start talking about a class, I want you guys to flip to page 437 in your book. And I want you guys on a note card, on your note sheet, wherever. There are 5-ish rules. They really did it weird in the book, but there are 5-ish rules about redox reactions. And I want you guys to have these written down because they are so important, especially to know that these are listed in order of importance. If you find number 1 in a problem, and then you find number 5, number 1 is more important than number 5. And you'll find that sometimes these steps disagree with each other. And so you got to take the first ones more seriously than the last ones. That sounds like a mess of words right now, but I promise it's going to make sense. So pause the video, write these from the book in your own little area. I'll be looking for that especially when I look for notes today. But speaking of notes today, hey, let's talk about redox reactions. Well, that's really zoomed in. Redox reactions, aka oxidation reduction reactions. So oxidation sounds a lot like it has to do with oxygen. Sadly, it really doesn't. Reduction sounds like something losing something. And we'll find out that that's also kind of a misnomer. I don't know who paid these scientists to come up with names, but I definitely wouldn't have given them money. I probably would have paid you guys before I paid them. So what is a redox reaction? A redox reaction is a reaction involving electron shifts. A reaction involving electron shifts and transfers. So if one element loses electrons and another one gets it, that's a redox reaction. If something just gains them, it's still a redox. If something just loses, it's still a redox. If there's electron movement anywhere, it's called a redox reaction. So, let's get those definitions down. What is oxidation? Oxidation, my dear friends, is when an atom loses electrons. Oxidation is when an atom loses electrons. And electrons are negatively charged, right? So if you're losing electrons, you're getting more positive. Think about electrons as chores. The less chores you have, the more positive you get. Reduction is when an atom gains electrons. This is what throws most people off. Reducing something means going less, but you're getting more electrons. But what happens when you gain more electron? You get more negative. Your charge decreases. That's what it's talking about. The reducing is the reduction of charge. -4 is less than -1. That's a reduction. You're going less and less. Okay? Pause the video if you need to finish copying, and then we will continue. So, step 1 is what we're going to be calling oxidation numbers, okay? And I learned something that I really shouldn't have about what I can do on this program. Check this out. I can grow my own periodic table on the page. How sick is that? So, what I've done is I have, oh, I can even point to them. This is so fun. I'm having too much fun today. Okay. We need to figure out how do I get my oxidation numbers? What the heck is an oxidation number? So an oxidation number is a glorified term for a charge. The charges can change based on your compound, but generally each element has an assigned charge. Those charges are often really affected by these rules. Notice it says that things in group 1 have a charge of +1, things in group 2 have a charge in +2, and that's usually the pattern you have. So for in group 1, your charge is nearly always a +1. For things here in group 2, with magnesium, those are always +2. Now skipping all the way over to boron, which is technically group 3, so no, we're moving the wrong thing. Why am I a boomer? There we go, boron. So boron being group 3 would be +3. Now carbon can change, it's either plus or minus 4. It's plus or minus 4 depending on what it's connected to. Normally, it's +4. But if it's connected to something else, it can be -4. In other words, if you have a C with 4 H's around it, the 4 H's are all +1, so the carbon will be -4 to balance it out. We'll talk about that more later. Nitrogen, we're starting at negatives here. So if we're 1, 2, 3, 4, now we're going to be 4, 3, 2, 1, but it's -4, -3, -2, -1. These guys over here are happy. They don't really have one. So that's where we're going to get our charges, okay? So if I said potassium right here, that would be a charge of -3. If I told you hydrogen, that would be a charge of +1. If I told you aluminum, that would be a charge of +3. That's where we're getting these oxidation numbers, okay? Let's shrink my table back until we need it. Also, if you don't have your periodic table out, now might be a good time to get it. So now comes the question, how on earth do we put this into practice? Why does this matter at all? I lost my red pen and I want it. Here it is. How do we use this? Oh, actually, my periodic table doesn't need to shrink and go away. I can still use it. Let's move you over here. Tra-la-la. Great. So, if I have an equation of 2 magnesiums plus oxygen gas gives me 2 magnesium oxides. My assignment for you is going to be to figure out how do I tell what my oxidation numbers are in each piece. Okay? Let's look through our rules Let's talk through our rules real quick. Number 1, free atoms, pure elements, have a charge of 0. Do I have any pure elements here? Why, yes I do. In fact, it looks like my magnesium has nothing else with it, is it? It's just a little friendly magnesium all by itself. So let's write a 0 above it. My charge for the magnesium is 0 because it's, number 1, a free element. Let's look at our second element. We have an oxygen. Well, guess what? My friendly little oxygen also has a charge of 0 because guess what? It's a free element. All right, let's look over here. Ooh, this isn't a free element, so I'm going to have to keep working. Number 2 says the ion charge gives us the oxidation number. And number 3 says the compound sum, this is a compound, this applies, has to be 0. All right. Number 4 says group 2 gives me +2. Where's magnesium? Magnesium is in group 2. So group 2 is supposed to be +2. So magnesium is going to be +2. Now what does it say the compound sum has to be? 0. So if this is +2, what would I have to add to it to make it 0? +2 on one side, -2 on the other, squished together to give me a 0. So my oxygen has to be -2. And does that make sense with the periodic table? -1, -2, there's my oxygen, it is -2. Fantastic. So what I want you to notice here is we had a change. My magnesium went from 0 to +2. My oxygen went from 0 to -2. This is a little bit of foreshadowing, but when an atom gets more positive, it's oxidation. So which one got more positive from 0? Oxygen went from 0 to -2. That got more negative. Magnesium went from 0 to positive 2. That got more positive. So my magnesium underwent oxidation. My oxygen went under reduction. That's where these numbers are coming from. But right now we're mainly going to focus on how do we label these silly little equations. Let's look at another one. 2 sodium plus chlorine gas gives us 2 sodium chloride. All right. Well, let's check this out. So, number one, the free atoms are going to equal 0. Hey, the sodium's all by itself, that makes him 0. Oh, so is this chlorine gas, that's got to be 0 too. Ooh, that's not nicer. We're going to have to figure this one out. Let's see what rules we have. Okay, that doesn't have anything to do with the compound. Ion charge is oxidation number. No, not really, this is a compound, not an ion. Compound sum is 0. So these are going to have to add together to give me 0. Group 1 is plus 1. Oh, look at this. Sodium is in group 1, and group 1 is plus 1. So I know my sodium. Now let's see what it says about chlorine. Chlorine. Chlorine's in group 17, so it's supposed to be negative 1. Does that work for us? Negative 1 plus positive 1, does that give me 0? Yes, it does. So I'm done labeling. Start thinking in your head ahead. What's happening? Which one's being oxidized? Which one's being reduced? Which one's getting more positive? Oxidation gets more positive, so which one is oxidizing? Looks like my sodium is oxidizing. Looks like my chlorine is reducing. Number 3. HCl plus H2O gives me hydronium, oh, that friend is back, plus chlorine with a little minus. Okay. And just so you guys know, I'm getting this from page 438. This is one of the example problems. So, I don't have any free ions, it looks like. Or I don't have any free atoms. Even the Cl isn't free because it's stuck with a little negative. It's not just a plain old atom. So free atoms, number 1, not really relevant. Number 2, ion charge is oxidation number. Hey, ion. This is a charged element. So if Cl minus, if that's an ion, then it's going to be its oxidation number. So what's the charge of Cl? It's right here. That would be minus 1. So my Cl is minus 1. Okay? Because the charge is negative 1. So the ion charge turns into the oxidation number. That's what that means. Number 3, compound sum is 0. We can't really work with that yet. Group 1 gives me plus 1. Do I have anything from group 1 here? Do I have any H's, NA's, K's? I have an H, which makes my H plus 1. I have an H here. That would have to be plus 1. Oh, I can't see it. It's too dark for some reason. There we go. My H here, that would have to be plus 1. Okay, looks like I got as far as I can. Group 2 is plus 2. Do I have any magnesiums, calciums, anything like that? I got a chlorine, oxygen. No, that's not helping me. H is plus 1 or minus 1. Well, that doesn't help me much. Oxygen is negative 2 or negative 1. It's so rarely negative 1, we can almost exclusively say it's negative 2. Oxygen is negative 2. Do we have any oxygens? Yes, we do. This is supposed to be negative 2, and this is supposed to be negative 2. Quick note on this problem, if you're wondering why these didn't have to follow the rules, and these didn't have to be balanced, because 3 plus 1s gives me plus 3, and this O is a minus 2. That doesn't follow rule 3 that says they have to balance out to be 0. Well, the reason that doesn't have to follow the rules is because the higher on the list a rule is, the more important it is. Number 2 says that the ion charge becomes the oxidation number. What was the charge on this? A plus 1, which means if you add a plus 1 and a minus 2, plus 3 and a minus 2, you end up with plus 1, which is that plus. That's why it doesn't have to follow the rules. Let's continue. Cool. And now we got to deal with this chlorine. Where are we going to find this chlorine? Groups all the way at the bottom. Group 17 is minus 1. Does minus 1 balance out with plus 1? Yes, it does. All right, so I have a plus 1 and a minus 1. 0. That fulfills my rule number 3. I have 2 hydrogens, so that's 2 plus 1s, which would be plus 2 and minus 2. 0. I have 3 plus 1s. I have a minus 2. Well, it looks like this one's not going to end up balanced. Okay, and then the plus Cl, and that's a minus 1. All right, so what happened to my H's? My H's stayed the same. What about my O? Well, my O stayed the same. What about my Cl? My Cl stayed the same. Everything kept its charge. And I said a redox reaction is when we have a transfer and a shift of electrons. So is number 3, is this a redox reaction? No, it's not. It's not because there's not a transfer happening. And looking at my work, it agrees with their book answer. Hooray! Number 4, and the last example I'm going to do for you. 2KClO3 ew gives me 2KCl plus 3O2. Well, this is going to be annoying now, isn't it? Let's look at this first chunk right here. If you don't understand this first chunk, I have a video specially for you, and it's in the description. If you don't understand where I'm getting my numbers for this one, watch that video. I promise it's going to help. So, let's go through my rules. Free atoms are going to be 0. Do I have any free atoms? Hey look, an O2 without a charge. That's going to be 0. That's not free, that's a group, okay. No, nothing I can do here. Number 2, ion charge. Do I have any floating negatives or positives? Nope. Compound sum is going to equal to 0. That's not going to help me yet. We'll keep that in our back pocket, though. Group 1 is plus 1. Group 2 is plus 2. Do I have any plus 1 or plus 2s? I see a K. K is in group 1. So that's going to have to be plus 1. And that's going to have to be plus 1. All right. Cool. What's the next rule? H is going to be plus 1. I don't see any H's. O is going to be minus 2. Oh, I do see a minus 2 right there. And I see a minus 2. That's not part of a compound, so it doesn't count. Okie doke. Last thing I'm going to have to worry about is the Cl. So, this is what's going to get tricky. The Cl is in group 17, which means it's going to be minus 1. If this is a minus 1, that gives me negative 3. In fact, this 2 is happening 3 times. That's negative 6, negative 1. That's negative 7, and a positive 1. Does that balance out to be 0, like rule number 3 says? No. So I'm going to have to follow rule 3 first, because that came higher on the list than all the way down here. Rule 3 says the compound sum has to be 0. So these 3 O3s, right? Or I'm sorry, these 3 O's are each negative 2. So that's negative 2, negative 2, negative 2. That gives me negative 6. This K gives me plus 1. So these together give me negative 5. How do I balance out a negative 5 to get 0? It would have to be plus 5. So my charge on my Cl is plus 5, even though it's negative 1 on the periodic table. This is the stumbling block for a lot of people in redox reactions. Please watch the video. Even if you do kind of get it, watch the video, it'll help. This has to balance out to be 0, so this plus 1 is going to balance with a minus 1. That just happens to work right. Okay, so let's compare. My K's are both plus 1, nothing happened in there. My Cl is going from plus 5 to minus 1. Ooh, that lost a lot. And if it loses, what is it? If it loses electrons, or I'm sorry, if it gets more negative, then it's going to be a reduction. Got to be careful with how I say these things. O goes from -2 to 0. It gets more positive. What happens when something's getting more positive? It's oxidation. So my O is being oxidized. Okay? So for homework, all I want you guys to do is on page 444, you have question number 2 right here. It gives you 3 questions. It asks you, is it a redox reaction? In other words, is there a change in charge? For each redox reaction, tell which element is oxidized and which is reduced. Did it gain charge or did it lose charge? Did it get more positive or more negative? Figure those 3 problems out. Send me a picture of that with your notes today, and we will call it a night. Happy Monday. Good luck. Let me know if you need help.